Me and John bought these dirt bike rollers for $500, and the challenge is to see which one of us can build the most powerful and versatile dirt bike with a budget of under $1,000. I scored a deal on this aluminum frame and this Gixxer 750 engine that I picked up for $25 from my local junkyard. It was missing a head though. So one of the biggest challenges is trying to get the aluminum frame to work, as it's a lot weaker and harder to fabricate than a steel frame. So John's staying in Pennsylvania, I'm going back to Tennessee, and we only have 2 weeks to finish these crotch rocket swaps. I might see if I can design a custom billet clamp. Let me grab our rubber mallet. Triple trees were very stubborn. Now this aluminum frame isn't the best. You know, you have wear marks here on both sides from the fairings, a couple little dings and dents, a stripped steel bolt here, a gash here, but it's nothing that I can't fix, and it should be perfectly usable. So I already know right off the bat the Gixxer engine is not going to fit in here, so we're going to have to cut the entire bottom cradle out. Wow, that's amazing. Well, there's no going back. Man, this 750, a lot bigger in here than I thought. I thought I was gonna have plenty of room, but nah, I cut up even more. Oh, you don't want that happening. I'm gonna build a little steel subframe around it to tie in this neck tube into the rest of the frame, make it nice and solid for jumps. Back in the day, I bought this giant 62 tooth sprocket for my Predator 212 swapped Hayabusa, and if you check it out, it looks like we might have lucked out, and it's the same pattern as this RMZ 450. So Creality sent me the Raptor Pro 3D scanner a couple months back, and I've been using it, and I've got to say I've been blown away. The fact is that now the average consumer can get high precision 3D models in their garage quickly and reliably. The Raptor Pro uses an advanced combination of 22 cross laser lines and 7 parallel laser lines, plus NIR Structured Light technology, giving you the flexibility to scan everything from small, detailed parts to large-scale projects up to 157 inches or 4 meters in size. You can even do body scanning. As Superfast Matt has shown, you can do wheel alignment with a 3D scanner. And when it comes to accuracy, the numbers speak for themselves. It has an accuracy of 0.02 millimeters plus 0.08 millimeters per meter, and that ensures exceptional fidelity even on larger objects. The scanner captures up to 660,000 points per second at 60 frames per second in laser mode and up to 30 frames per second in NIR mode. That means less waiting and more creating. One of the standout features is the ability to scan black and reflective metal objects without needing sprays or surface prep. Combined with 24-bit full color scanning, you get models that aren't just dimensionally accurate, but also realistic. To put it to the test, I scanned this Hayabusa clutch cover, and after cleaning up the mesh and included software, I was able to modify the design and 3D print a custom replacement part. This combination of speed, accuracy, and flexibility makes the Raptor Pro more than just a scanner. It's a bridge between the physical and the digital world. So whether you're an engineer, a maker, or a business looking to bring your ideas to life, the Creality Raptor Pro 3D scanner delivers professional grade results in a package that's fast, versatile, and ready for your next big project. Alright, so we're going to start off by scanning this Hayabusa clutch cover with the Creality Raptor Pro. Wow, dude, it's actually working pretty good. I did try this already on my Windows laptop, and it did not want to pull this software, so you do need a pretty beefy computer or a pretty beefy laptop, but right now I'm getting like 40 frames and a lot of noise in the picture, but overall not bad for the first try. So I was able to use Creality's software to delete a lot of the noise from the scan, which was super useful. I will say you do need a pretty beefy computer for this, so make sure all your specs are up to date, and the scanning itself took me about 10 to 15 minutes. So now I should be able to import this into Fusion 360, and so if I want to make like a billet clutch cover or like a mold for a carbon fiber part, this just saved me like countless hours of measuring it all by hand and extruding it. So we should be able to just import. So this is the finished clutch cover. It looks exactly like this one here on my desk. See, there is some noise here. I still gotta work on improving that, but for a first time it's really not bad. So now we can basically export this file as a STL, and just like that we have this clutch cover in Fusion 360. We could now trace it and make a template of it, which is pretty freaking sick. Alright, huge shout out to Creality for sending over the Raptor Pro and sponsoring this video. They're going to have a custom discount code down below for you guys, so check it out. I mean, this is a pretty affordable 3D scanner, one of the more affordable ones on the market, and this is going to change the game. So now I could basically scan cars, fender wheels, inner fender wells, engine bays and whatnot, design turbo kits, and I mean, this is going to be a huge game changer for my channel. So huge thanks to Creality for sending this one out. So after a bunch of painstaking grinding, we finally got the sprocket on, and I don't even know how true this sprocket is going to be, but yeah, we got it on there. It was actually a lot more dremeling than I thought. So I built a little jig to hold the motor on the welding table, make sure it's all straight and true. And then I went ahead and put the aluminum frame over and realized there's not that much room to work with. I need to go ahead and cut this off, cut these off, and we're going to go ahead and slice this section, make a seam like right here, so we could basically shove this hole closer to the sprocket. The closer it'll be to the sprocket, the less chain issues and all that we're gonna have. So we got it trimmed up here. The sprocket clearance is looking way better. Here it's looking way better. So I'm able to put air filters on these two, but these two I'm gonna cut and angle them out so I can put air filters on. What I'm gonna do, there's a stock hole here. I'm gonna drill through. There's gonna be 2 plates on each side of this, and there's gonna be a steel subframe to tie in these two, and then down all the way up into this point right here to catch that mount as well. This one we won't need to do. We can, but we won't need to. I grinded the bottom of this dirt bike flat. We're gonna drill 2 holes and have a steel plate that mounts over there. And of course, we gotta go ahead and plug up this huge gaping hole. So I got a piece of aluminum cut out, and I'm gonna use my HTP Invertec 301 TIG welder to get this thing filled up. And then from here, it's as simple as connecting the one engine mount to the bottom engine mount. And I did cheat a little bit and use 2 different tubes. got the cradle almost done, and here's the realization I came to. So when I go and drop the cradle to pull the motor, I don't want the motor to come with the cradle. I want the motor to stay attached to this aluminum frame, right? So I'm gonna go ahead and make some tabs and weld them to the aluminum frame, just on these bottom mounts here, and that will be enough to hold the engine in place so we could remove the cradle. I also made it to where the oil pan is completely serviceable. Let's say I bust it on a rock in the field, I will be able to drop it without pulling the subframe off. So we're getting really close to finishing this swap up.
So I'm gonna go ahead and weld out the cradle, install our subframe, our seat. The bike was missing a shock, but I found one on Facebook Marketplace with an upgraded spring. Since we're adding like 100 pounds extra to the bike, we're gonna need a much beefier spring, and I'm hoping this will do the trick.
If you're building something custom, here's how to set up the chain without it skipping or giving you issues. So draw a line from your swing arm bolt to your swing arm pivot, and the sprocket should land somewhere along that line. Doesn't have to be perfect, but the closer you can get it to the line, the less chain issues you'll have. And you also want the sprocket to be as close to the suspension pivot as possible. The closer you can get that distance, the less your chain is going to stretch and shrink as the suspension travels up and down. So the closer you can get that distance, the less chain skip issues and binding you might have. As the swing arm pivots away from that sprocket, the chain is going to get tighter, and that's when the chain decides to let go. Well, ladies and gentlemen, the RMZ 450 is officially a roller, or I should say RMZ 750. This thing is a little bit more intricate than I thought. I'm not going to be able to finish it in this episode. The gas tank is going to go here. There's a lot of dead space here, so perfect room for the gas tank. The radiator is probably going to go up front. I don't know how I'm going to fit them, because that's a big engine. The billet clamp should be coming a couple days. The shock came with an upgraded spring, which is like the perfect weight. So that set me back $116. I don't know if it's just me, but this dirt bike looks smaller than I remember. Like, I thought dirt bikes were a lot taller. I guess not. Maybe it's just the engine is so huge, it takes away from the dirt bike-ness. So if you enjoyed this video, leave a like, drop your thoughts and comments down below, and as always, I'll catch you next episode. Stay tuned, peace, and God bless.